Hello everyone, my dear students, programmers, anybody who is interested in programming. Um, Today is our last lesson in object-oriented programming with Python course. So basically in seven short video lessons, we covered uh, the most essential ideas of object-oriented programming. And I'm doing now just a review. I'm going again one more time through the coding just to recap, reinforce your knowledge. And we did first 4 lessons review yesterday. And today I'm going to review last 3 lessons. It's about object-oriented design, how to build new objects, new classes based on the existing ones. So we are going to again take a quick look at composition, inheritance, and polymorphism. So you see those 3 classes I'm using in my course. And the first step is composition. So I'm trying to build a new class box based on 6 rectangles. And again, I encourage everyone to type the coding, to try it. So I can scroll, I can show you my existing class, rectangle, constructor, getter, setter, another getter, another setter, grow, shrink, and drawing methods. So I'm trying to now reuse rectangle objects in my new class, which is called box. So the main idea is you have to instantiate in your new class constructor all the objects of the old class. So you see, I instantiate 6 rectangles. So one rectangle at the front, another at the back, left rectangle, right rectangle, top, bottom. So it's obvious any box consists of 6 planes, and we using for the outline pipe character, vertical line, or pipe sometimes we call it. Basically I redefine on my new class grow and shrink methods. So you may see this is also an example of polymorphism, which is discussed a little bit later. So the same methods with the same name can work on different objects. So grow is calling rectangles grow, and shrink is calling rectangles shrink. An interesting detail here, I implemented str method in order to print information about box. Let's take a look at the test. So remember, we are moving, discussing OOP, we always moving from developer's perspective to user's perspective. So how to use it? So you see, line 3 box is instantiated. When it was instantiated, 6 rectangles were instantiated as well. I want to see my box line 5. I want to shrink it line 6. I print again the information about box after shrink. And then I show you how you can use still all the embedded objects methods. You see how to access embedded methods. Now you need double qualifier, And you see I can still draw my rectangles. Line 11, I can still shrink them. And let's prove it. Let's see. Yes, box instantiated. After shrinking, you see it got smaller. And you see I can still use embedded objects methods. So that's a composition. Composition is technique to embed into a new class existing objects as instance variables. Good. Inheritance, maybe more advanced technique to reuse classes. And let me open now the coding. So rectangle class. I now gonna inherit. So I create rectangle with the fill, more advanced class with more features. It's called filled rectangle. Sorry, that's not what I mean. Where is my filled rectangle? That's the one. It's pretty small, by the way. So what happens now? What's the difference between composition and inheritance? So you now build a new class based on the existing class. You may have extra instance variables. In my case, it's field, so my new class has more instance variables. You may have more methods, which we're going to discuss later. And the most important thing again, in the constructor, you have to call your parent constructor line 6 before I initialize extra instance variables. I have to make sure my parent class or base class instantiated. And then I can use everything my parent class has. So basically when you inherit, everything which parent class does automatically is yours, but you can also add new stuff to your existing class. So I show you now the example. Field rectangle instantiated. I can still call existing class methods, but probably they're not satisfactory because they do not take in account the field character. So let me show you. Yes, draw and shrink are good, but they, at least draw should be improved. Shrink is good. I can still reuse it on my child class or derived class, but draw obviously has to be improved. So one more step, I'm now redefined. So that's the beauty of the inheritance. You not only taking everything, you not only adding stuff to existing class, you can also change something in your existing class you don't like, you're not satisfied with. So let me open again the base class. Unfortunately, we do not have consistent terminology, so some languages we describe this relationship inheritance as base derived classes. In some languages we prefer parent child terminology, In some languages like Java, we prefer superclass and subclass terminology. So super is a parent, subclass is a child. Okay, so let's fix it. Now I'm trying to fix my field rectangle. And what I noticed, basically, in order to make it work, I can reuse from my parent class draw top method, draw bottom method, but I can just redefine or overwrite one method in my parent class. It's called draw middle, and then I should be fine. So just with this small change, my new class basically does everything I expect. So let me open the test. Let's now again move to the user's perspective. And you see in line 3, I did rectangle instantiation. I draw it. And then I did field rectangle instantiating. And look, I save it in the same variable. And I draw it again. So basically, that's an example of polymorphism. You see the same code, but different results. Absolutely the same lines going to produce different output. Why? Because here in my R variable, excuse me, I have rectangle object, but here I have field rectangle object. So based on the runtime information, Python interpreter going to call the right method. So the same method draw is working differently on different objects. Let's prove it. Let's save it and let's run it. And you see, yes, first rectangle, second is field rectangle. So congratulations, we finished our object-oriented programming course with the Python. It was 7 short lessons plus 2 lessons review, recap. But I think it's not enough. In order to understand OOP, you have to practice. So the next course, which I'm going to start tomorrow, is how to apply object ideas. They seem to be right now maybe abstract, theoretical, so how apply them to real life applications, Windows applications with the widgets, menus, graphics. So let's dive into tkinter. Tkinter, it's a framework, library. Python has to create graphic user interface apps, and we can see now OOP concepts in action, in real life. So I don't say goodbye. I'm looking forward to see you again. As usual, I appreciate your likes, your comments, and of course your subscriptions. All the best, guys, and see you soon. Bye-bye.